So we want everyone to fill in this page, and a little bit of this page before we get to class. This is the easier material to understand. And then in class, we're going to look at how to deal with prefixes. When we have units, we're going to look at how to deal with volume, and we're going to look at density. And at the very end, we're going to look at accuracy and precision. And then we'll have our student learning indicators again. So the first 2.5 pages, we're doing before class. So we're going to go back to those. Let me get back up there. So we'll open this up really wide. So the first question is, what is matter? And if you've ever had chemistry before, you know what is matter. It's everything that has mass and it takes up space. That's what matter is. As a little note too, matter is made up of atoms. Several of these pictures come from OpenStax, but if you click on this link, of course, it will take you to the section of OpenStax that we're working with. So the kinetic theory of matter, it explains the difference between the states and the phases of matter. So the kinetic theory, it says that matter, what we were just talking about, everything that has mass takes up space, consists of small particles called atoms in random motion. So if you look carefully, you can see that there are 3 phases. We have our solid phase, we have our liquid phase, and we have our gas phase. There's a 4th phase that we don't talk about as much, and it's called plasma. It's in the sun. It's also in certain kinds of TVs. It has to do with ionized particles. So we're not focusing on plasma right now. What we are looking at is what the solid, liquid, and gas, what their properties are that they have in common and how are they different. These circles represent the atoms, and they actually, and you can't tell because it's a static picture, but every single one of these little circles in here, they're all vibrating. So instead of it being like a blank picture, it's like jittering. All those little atoms are jittering. And then over here, all these atoms are also jittering, and they have more space to move. And then finally, these atoms have so much space to move. Of course, they're jittering and moving really fast also. So what is the difference, both on the large scale, the macroscopic scale, and the microscopic scale? What is the difference between them? So how are solids and liquids different from gases? So you know that solids have a fixed shape. It doesn't matter what I do with this solid. If I roll the flask around, that solid isn't going to change shape. We know that the liquid has a fixed volume. So I can move it around and I can pour it into another flask and it's still going to have the same volume regardless of what kind of container I put it in, as long as the container is large enough. And it's going to stay at that one volume. But the gases, if I were to move this section of gases into a larger flask, the gases would spread out and fill it out completely. So they do not have a fixed volume. Now, on a molecular level, how are they similar and how are they different? So you look right here. These are very closely spaced. If you look at our liquid, they are still pretty close, but they are not as close as the solids. And you'll notice that the gases are very far apart. And then this is a thinking for yourself question. As heat or energy is applied to a solid, liquid, or gas, what happens to cause it to change state or phase? That means that what happens when you heat a solid up? And imagine this is like ice or something. What happens when you heat ice up? Then what happens when you heat water up? So as it's applied to a solid or a liquid, the solid will turn into a liquid, and then the liquid turns into a gas. And what happens to these little particles? Well, if we heat them up, we're giving them so much energy that they start bouncing off of each other and they start moving away from each other. And it makes it more like this situation over here. Or if we give this one a whole lot of energy, they start moving and bouncing so hard against each other that it turns more into this situation. That actually is the kinetic theory of gas. There are things that are holding different forces that are helping to hold these tight together, but the more energy you put in, the less ability those forces have to hold those things together. So go ahead and take a moment for yourself and fill in these questions.